So I want to explain the differences between the two oxygen isotopes. So if you remember, an isotope is an element that either has more or less neutrons. So all that does is either make it heavier or lighter. So normal oxygen is oxygen 16. It has 8 protons, 8 neutrons, 8 electrons. However, we see an isotope of oxygen, which is oxygen 18. So it has 8 protons, 8 electrons, but it has 10 neutrons. So it is heavier than normal. Now what's important is when we look at ice cores, okay, we can go back into the Antarctic and take a whole bunch of ice cores and look at these samples, we're going to see, or in thorium shells, right, we can see both of these oxygen isotopes. Now looking at these oxygen isotopes tells us something about the environment. So oxygen 16 is physically light. It's lighter, and oxygen 18 is heavier. So what we see is when it's really cold, it gets really dry, which means, so let me switch here, so when it's cold, that means it's dry. So that means everything is evaporating. So if it's evaporating, right, here I am on the ocean floor and I have oxygen 16 and oxygen 18, which one of these two is going to evaporate out easier? The light one or the heavy one? We said the light one. So in cold and dry conditions, we see more oxygen 18 getting preserved. When it is warm and wet, here we are on the ocean floor, we have oxygen 16, oxygen 18, nothing is evaporating. So we see more oxygen 16. So just by looking at the distribution of these two different isotopes tells us about the overall Earth's conditions.